This is the Excel tutorial for IB Math Studies on processing your data for the internal assessment. So what I'm going to do is I'm going to run through a hypothetical example of some data that I've just kind of made up and how we need to process it for the internal assessment. So my study that I did was the effect of height in inches on men's shoe size. So, for the record, this is a crummy project. I wouldn't have approved it because the two are clearly associated from like a biological fact or situation, but it just makes a convenient example. So, one sheet that I have is going to just be my raw data. So here is all of my raw data. You can ignore these tables over here for the time being. And I've gone and it's not organized in any way, it's not sorted. All I did was remove the responses that were nonsense, like the person that said they were 6 inches tall and had a shoe size of 157. All that stuff I just deleted out of there and didn't count it. So I have 50 data points here. So that should be one tab of my Excel. I've named that tab raw, so if you just hit right click and then rename, you can name your tabs. What I'm going to do now is I'm going to start processing some of this data. So if I go and look at my description of the internal assessment, things that I need to have a scatter plot of my raw data. So Excel can do this really easily. So I'm going to highlight my columns of data. Does not have to be sorted. Notice I did include the headings because that'll save me a little bit of time. And then I'm going to click the Insert tab. And then I'm going to pick this kind of scatter. So it says Insert Scatter. And I don't want any dots in there or any lines connecting it, so I'm just going to pick this. And notice that I have what looks to be like a crummy little scatter plot here. And it's crummy because everything is kind of crammed in this corner. If I click on this, I can add in something. So I'm going to add in some axis titles. And I'm going to add in a trend line. And I don't think I need a legend here for that. Okay. So for this axis title, this was my height. Notice I just double-clicked on the title to be able to type in there. Okay. Now what I'm going to want to do is, since all this data is crammed in this corner, let's spread this out a little bit. That's not what I want to do. Let's just click on this. So when I click on the left axis and I right click on it, it opens up this option. So I'm going to change my minimum for the x-axis. Instead of starting at 0, let's start at, say, 60. And my heights, instead of starting at 0.4, let's go up to, wait a minute, I'm looking at the wrong axis. So click on this one. Instead of starting at 0, I want to start at maybe 6. So there we go. That's a little bit better. And now I'm going to right click on this and hit Move Chart. And I'm going to have that appear in a new sheet. So here is my full-size sheet of paper chart. And I'm going to just, I don't know why that moved to there. I'm just going to move that floating in the middle of my chart. Okay. And this is really height versus shoe size. Okay. I'll go back to my raw data now. It also asks me to find my mean and standard deviation for both of your variables. So I'll do my x mean and my y mean. So what I'm going to do is I'm going to use a formula now for Excel. So I'm going to start by doing an equal sign. And the formula I want is just the average. That's the same thing as the mean. So I start typing and I see that there's lots of different formulas. If I click one, it'll tell me kind of what it does. The one I'm going to use, though, is just this first average. I'll double-click that, and it's imported that formula in there. And what I'm going to do now is I'm going to click on cell 1, and then I'm going to just hold down the Shift button and the down arrow, and highlight all of my data in that column. And then put a parenthesis at the end of my formula here, and press Enter. And now we'll do the same thing for our y's. So double-click average, put my cursor into the shoe size, hold Shift and then press the down arrow, highlight that whole column, close the parenthesis in my formula, and then press Enter. Okay. Next thing I'm going to do is do my standard deviations. So I'll do one for the x's, and then one for the y's. Get a little wider. So I'll do equals. And the one that we want to do for the sigma x, this is going to be the one that you want to use for yours is this one, standard div p. So this is the population rather than the sample. So we're going to do a population one. So I'm going to highlight all of that. Again, doing the same thing that we just did. And then equals standard div population, double click, click in there, highlight my whole column, and okay. Next thing I need to do is find a correlation coefficient. So to do that, I need to actually have, in addition to my population standard deviation, I'm also going to need my sample standard deviations. Maybe I should be a little bit more specific and include a pop in there. So 1. And the reason I need this is because I'm going to need that value to calculate my R. So the standard div S is the sample. And that's just this whole column. So again, highlight the whole thing. Equals standard div S. Double click. Highlight my whole thing there. Close. Okay. And now I remember that my R value is going to be 1 divided by 50 minus 1, because I have 50 samples. Actually, let's do this first. We're going to have the 3 columns. So I'm going to insert another column here. So this is xi minus x mean divided by the sx. And then we'll have yi minus y mean divided by sy, and then we'll have the product here of them. Remember, this is just how we calculated the standard deviation. So what I'm going to do is I'm going to do the height. So I clicked in that cell, and then minus. I'm typing a formula now. And then my value for x mean. And I want that value for x mean to stay the same. So I'm going to go and insert a $sign in front of the number and the letter. What that $sign does is it locks that cell. So in this formula, I'm going to Excel can go and import this formula over and over and over again, but it'll change the values for like the h and the 2 here if I don't put the $sign there. But since I'm always going to be using the mean, I always want that to stay the same. And then I'm going to do the same thing with the sample standard deviation. And I'll press enter. And then I'm going to just grab the corner of the cell and drag down. So again, the little square here in the corner, see my cursor change from white to black. If I just grab that with the left mouse button and drag down, it'll go and import, do that formula over and over and over again. And you see what's happening is I'm just taking each individual height and then subtracting the mean and dividing by the standard deviation. And because I use the $signs there, it locks those. So now we'll do the same thing for the y's. So same sort of thing. Again, I'm using $signs on the mean and standard deviation because I want those to stay the same. And then we'll drag down. So that's that. And then the product, I just want this one times this one. Again, this is just like what we did in the table and what we did on the calculator. So there's all of those. Okay. So now we're ready to do the r. So we'll have 1 divided by 50 minus 1 times, and then I'm going to use, I want to add up that whole product column. So I will do the sum. That's a Excel formula. And then I'm just going to highlight this whole column. And then press enter. And here's my R value. So not fantastic, but not terribly horrible. I'm going to just believe in the directions. I ask for 5 decimal places, so I'm just going to go ahead and extend those out so I have 5 decimal places. The next thing I do is I ask for the least squares regression line. So one thing that I would say to this is if your R value does not support a linear relationship, you should not do this part. You should say in your paper, though, that like because my R value is bad, close to 0, that this data does not have a linear relationship, so there's no sense in doing a regression line. I would say 0.6 is just kind of on the borderline of whether you should do it or not. So I'm going to do it just to demonstrate that how to do it. But in general, if you had an R value that was bad, you would not want to do this part. And you would say that you don't want to do that. So again, the formula here for finding A is the R value times the sample standard deviation for the Y's divided by the sample standard deviation of the X's. And then the B is the y mean minus your A value times x mean. And notice when I'm doing this, I'm never typing the numbers in. I'm always clicking on the cell and using the cell, because really in here, this number has all like hundreds of decimal places, and Excel will carry like hundreds of decimal places. So your answer is much more accurate doing that, and plus it saves a lot of time where you don't have to type in all that nonsense. Going down, it says that we want to draw your least squares regression line on your scatter plot. So if I go and look at my scatter plot, notice I did already put that on there. And if I click on Format Trend Line, I can have it display the equation on the chart. So you just move that somewhere where it's kind of convenient looking. So I put it right there. And that's nice. And you notice that those numbers match what we saw over here. So everything looks good. The next thing we ask you to do is form a two-way table. So that's what I'm going to do now. So I'm going to fill in this two-way table. So to do that, I want to figure out kind of different categories to break up this data in. So I'm going to highlight all of my two datas, and I'm going to start by sorting them from biggest to smallest in heights, so I can kind of figure out how I want to break the heights up. So what I'm going to do is click the Data tab, and I'm going to click Sort, and I want to sort by height, and I want to go smallest to largest. Now it's important that you highlight both columns, because it'll move the corresponding shoe size with it. You don't want those to get separated. So you'll see that now shoe size starts at smallest and goes to biggest. And I'm going to try to make a 3x3 table here. You could also do a 2x3 if you have to, but I'm going to try to do a 3x3. I think that this data, when I made it up, should be spread out enough so that I can do that. So I'm going to look at how to break this up. So let's see, if I take this part, and then I take this part, and I'm just kind of eyeballing things here. There's no real rhyme or reason to what I'm doing. I'm just kind of saying, oh, that looks like about a third of my data. And that looks like about a third of my data. And that looks like about a third of my data. So now let's count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I have 22 in here. Maybe that's a little bit too much. That's almost half. So what I might do is I might actually take the 67 and dump it into this set. So now if I go 19 to 70, or 19 to 39. So I have 20 in there. That might be too much in there. So I think I'm going to take that 72, that last value, and dump it into the end here. And maybe I'll try this. That looks like I have about a third of the data in each one of those three categories. So here I have 17 in there. So we'll do 61 to, let's write it this way actually. We'll do bracket 61 to 67 parentheses. So I'm writing it like an interval notation like we would in an algebra class, and it said I had 17 things in there. And then we'll do bracket 67. So I'm including 67 in the second one, but not in the first one. That's why I have the bracket and the parenthesis there. To 72, parenthesis. And from 19 to 34, that is 15 16 of those, I think. And then we'll do 72 to positive infinity, basically. Or you could just write like 72 plus at that point. And let's see, we have 35 to 51, so that should be 16 of those. And I think I just miscounted because I should have 50 data points, and that doesn't add up to 50. Let's do this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Aha! And then I bet that one was 17, doing the same. Made the same mistake there. Okay, so that looks pretty good. I have an even spread of data there. Now I'm going to unhighlight all of this stuff. And I'm going to do the similar process now, but I'm going to do the y coordinates. Oops. I'm going to highlight everything, and now I'm going to sort the shoe sizes. So I'm going to sort shoe size from smallest to largest. And I'm going to try to do the same thing. So I'm going to look for about a third of the data. That looks like a little bit too much because that's all the way from 2 to 25. That's almost half of it. So maybe I'll go up to size 9 there. So let's try that. And then we'll go 10 and 11s probably. Seems like the next good category to grab. And again, nothing technical about what I'm doing, and I may have to go back and change this when I actually compute these expected counts here in a minute so that I make sure I pass that large counts criteria. But I'm just trying to kind of break this up so I have like an even amount in each one. And that might not even be possible for some of your data, but you just kind of play with it and do the best you can with it. So again, I'm going to do 7 to 10. Again, I'm going to use the parenthesis to imply that 10 is not included. So 10 to 12, again, parenthesis implying that 12 is not included. And then 12 to positive infinity. So in here I have, it looks like, oh darn, I have to count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then here, 19 minus 34 is 15, plus 1 is 16. And if I go here, 35 minus 51 is 16, plus 1 is 17. So I have, again, because this is just like I generated this myself, there's nothing special about what I've done here. So I'm going to now blank this out and then fill in the inner part here. So I'm going to unhighlight everything again. And I'm going to resort, this time again back to height. And now I'm going to go and look at, in here, the ones that I'm going to count. So I need a height between 61 and 66, and one that is shoe size between 7 and 10. So this one is good. This one is good. Don't count this one because 10 is not included. These three, though, are. This person doesn't get included, but these three do. And then this person gets included, but none of the rest of them do. So I have 2, 6, 10, 11 in that category. category. I'm now just going to pretend that I did the rest of them while you're watching. I have the numbers already counted and written down. So I'm just going to go through and fill in these values. I'm just doing the exact same process I showed you, but it's so tedious and time consuming I did not want to do the whole thing. So there's that. That's just me counting things up now that I made my divisions. And I still don't know if the decisions I made were good ones yet. So this is my observed counts table that I just filled in. What I need to know if I've done this, need to go back and redo this, or need to try to collect more data, is if my expected counts are correct. So remember, to calculate an expected counts, I'm going to do row total times column total divided by overall total. And if I do this column, I'm going to need that value of H15, everything in that column, is going to stay the same. So I'm going to do that and put the parenthesis there, the $sign there, and then obviously that total that I'm dividing by stays the same. And then I'm going to just drag down. So far everything looks good. And just to point out what I did, again, row total 16 times column total 17 divided by 50. Similarly here, row total 17, column total 17 divided by 50. So we're good. Do the same thing here. So we're going to do equals row total times column total divided by overall total. And if I'm going to drag down, the column total and the divisors are going to stay the same, so we'll put $signs there. And I drag down. And then my last one, row total times column total divided by overall total. And the column is going to stay the same, and the divisor stays the same. So do that. And I drag down. And all of these expected counts are bigger than 5, so I am all set. I am good to proceed. If this wasn't the case, if one of these was 4, 2, or 0 or something, I could have the option of eliminating one row or eliminating one column. So I have a 2x3 table. That is often an easy way to get things to work out. The other option would be to mess with these categories to try to even out how many things are in each inside of each one of the categories. But here, notice everything is pretty evenly distributed, so I knew that I wasn't going to have much of a problem. But if you had like 25 in here and 1 in this column, you're going to have issues. You're going to need to change these categories. And they don't have to be like, each one of these basically contains 2 to 3 shoe sizes. Or these ones contain like, 5 or 6 inches. They're pretty evenly made. You may have to make them so they're really uneven, just so that you have an equal amount of stuff in each category. Going down my list, I have more to do. So I need to do distribution percentages. So that's going to be the next thing that I do. So to do the marginal distributions, I'm just going to copy this table here. Oops. And I'm going to clear out the data that's in it, because I'm going to fill in the marginal distributions for this table. And I'm going to do something similar for the conditional distribution. So I'm just going to, again, copy and paste this table. So, one thing that I've want to make note of, that we put our independent variable here as the rows. That is kind of the standard. So we said that shoe size the dependent on height. So we have height as our rows and shoe size as our columns. And that matches up with our chart here, where we have height on the x-axis and shoe size on our y-axis. So I forgot to mention that earlier, so let's make note of that here. And now back to marginal and conditional distributions.